Hello, everyone. Welcome again. We are going for another very interesting keynote. After hearing about an European project, we are now going to London in the UK to hear about one of the most innovative engineering programs in the world, featured in the Global State of the Art in Engineering Education report from MIT, which I recommend all of you to check out. So University College London is one of the top ranked universities in the world with several faculties and a long history of successes. To tell us about the new integrated engineering program, we have Emanuela Tilley, the program coordinator. Emanuela is a mechanical and civil structure engineer. She has worked as a consulting engineer, leading multidisciplinary engineering teams. I hope you all enjoy. Keep in mind that you can post questions in the comments section, both in the YouTube stream and the Facebook stream. And without further ado, let's welcome Emanuela.
Thank you very much. Very happy to join you today. Great. Can you see that? Just to make sure. Perfect. Right. So I'm Emanuela Tilley. I've recently become a professor at UCL, and I'm the director of the Integrated Engineering Program. And at Engineering UCL, our tagline is Change the World. When we started thinking about how we would improve and revamp our offering, we thought actually for our students to change the world, they have to be taught differently. Just a little minute for you to get to know about UCL a little bit before I start. We are in London. We are very proud that we were the first in England to admit students regardless of their class, race, or religion. And we were also the first to admit women on equal terms to men. We're quite a big campus, quite a lot of graduate level studies, and we have quite a lot of Nobel Prize winners. There's lots of faculties. We have 11 faculties, one of which is engineering. And within engineering, we actually have 11 departments. So the integrated engineering program includes students from all of those departments. So how did it come about? One of the first things that kicked it off was reports back in 2007 and 2009, around that time when the Royal Academy of Engineers and industry partners, as well as the Confederation of British Industry, were saying that the students had what we would call a skills gap. And that theoretically our engineering students are very good. However, the skills, the communication, the self-management were lacking. And even in some regards, problem-based skills, problem-solving skills. So, and they also said that in order for universities to do more, they shouldn't just add these elements on, it should be embedded in how the students learn engineering. So our reaction was to do a curriculum review. So we started in 2011, and it took us 2 years to actually understand what we offered from across the faculty and how we can make it distinctive. So that the result of that is the IEP. We wanted to make it distinctive, we wanted to make it modern, and we wanted to give students a broader perspective because our students come into a degree and they graduate from a degree. And they're quite separate from all other degrees. So students studying civil engineering don't really ever intermingle with chemical engineering students. And we don't think this is modern because actually the real world engineers are working across disciplines. So what is the IEP? It's not an actual degree program. No one actually is recruited into it and no one graduates from it. Actually, it's a way of teaching that provides connected activities between the disciplines, so that our students do some interdisciplinary learning. They work with students from another department, not just one department, in many cases, many departments. There is a common structure, and it promotes practical applications and the learning of transferable skills, or professional skills, as we also call them. And this is all alongside the fundamental theoretical learning, or the degree program that the students have applied to. It's completely embedded in the student's chosen engineering degree from one of the programs or the departments that we have, and it's completely unique to us. I have to say that actually because our students don't actually realize that the way we teach engineering is not the way it's taught across the UK and in the world. So one of the first things we did was we tried to define what we believe engineering is. And this is what we came up with. We asked students and staff from across the faculty to help us create a definition that suits us. And this is what it is. So engineering is the art and practice of changing the physical world for the use and benefit of all. And the few things that really stood out for us was in engineering, there is a creativity to it. It is a practice as well. So we need to give our students plenty of practice and not just learning from textbooks. And there is an art to it. So they should be influenced by the humanities as well as the more artistic disciplines. And we need our students to understand right from the beginning that engineering is about people, and everyone around the world use and are affected by the work that we do. So we wanted that to be at the forefront of our definition. The other thing that really spurred us on in terms of the changes is lots of students, when they come into engineering, don't actually realize that it's quite a creative subject. And we don't want students like Virginia to not apply to engineering and lose out on coming into a career as well as our faculty. We want students like Virginia to come. Instead, she chose a liberal arts degree and an engineering pathway within it. So what our students do is a lot more practical building, making, modeling, and testing. You can see the students doing that here. And a very useful exercise in many ways is building the physical systems as well as analyzing them through models. So does the physical system actually work and behave as you would analytically? And that is a really interesting way of students learning. They also do quite a lot of group work, and I'm sure students from across engineering schools across the world do this, but our students do this from the first day. We put them into teams and they start designing on for real problems right from the first day. This is really daunting for our students, but we believe the more projects you take on, the more teams that you work in, the better you'll be at this, at both of these skills when you come to those ever more important third and fourth year or dissertations at the end of your degrees. So I just want to stress that our students don't work on toy problems, they're real problems. So for instance, here, this is a community in Peru that our students in first year work with, or they have done in the last couple of years. We like to change our projects every 3 to 4 years. So this community group was working with a foundation called WindAid, and WindAid goes around and puts up those small wind turbines. Now those wind turbines are very small. They're only about 5 megahertz, I think. So very, very, very small in terms of the power outage. So what we wanted our students to do was to create a power grid so that they could build it for a community of 40 huts as opposed to just the one individual hut. And they have taken our design on and ran with it, really. So we are putting our students together with real communities, even from the first year. So the way we teach engineering is in context, and that's a really interesting word for us. What it means is that we give the students information about the full problem. And of course, we understand that the principles of science will drive all of our solutions, it'll drive our research, and it'll drive our comfort zone, if you like, in terms of what we learn. Of course, we now expect all students to design solutions that are sustainable. That wasn't the case when I was doing my degree, or even, let's say, when we first started working this out in about 2011. If your solution is not sustainable and it's not safe, then it is not acceptable. It is not an afterthought. It has to be embedded. But I'd really like to point you to the left-hand side of this drawing, because our students from the beginning are also thinking about issues of risk, ethical considerations, social implications, environmental implications, and financial impacts. Those are just some of the few extra considerations or the contextual considerations that our students now are being faced with. And we build this up. So in first year, we work in the areas that are a little bit more comfortable, like lots of students understand environmental impacts and are also very good at understanding financial impacts because we have both the scientific and the mathematical backgrounds. But we also start introducing them to the very much more trickier contextual issues like the social implications. How are you designing something? What are the issues that perhaps the people that you're designing for may or may not find your solution desirable? And those are the hardest questions, I believe, to answer. But we get students to start thinking about it quite early on. The other thing as well in this program or this teaching framework is we get students to really develop their own skills. So industry, our industrial partners are telling us that they're looking for students that have communication skills and interpersonal skills. So that is the team working aspect. They also like students that are well organized and have that enthusiasm and commitment. And this is obviously over on top of, the rigor that comes with a UCL degree. But what I've highlighted here in the blue, it seemed to come up more and more. And there's not an easy way to talk about this. And lots of employers talk about it in a very anecdotal way. Like, I had a really good graduate employee once where she was able to, take some really minimal guidance. I pointed her in the right directions to do a little bit of research, and she came back to me with her ideas and even started on a plan. So that ability to start with a minimum is something that employers really seek, to kind of work with a blank sheet of paper, so that you can go and be autonomous in your own working and provide that value that your employer is looking for, is something that they really, really do like in our graduates. The other thing as well is that from the offset, when we started designing the program and the learning in it, we really aligned ourselves with some international reports. And one of them was the World Economic Forum, this future skills report that comes out. I think it's every 2 to 3 years. So we're due one fairly soon. It'd be interesting to see what it's like after COVID. But so we looked at 2015. Probably about after the first year that we were implemented our program, and then again we look through and make sure that the skills that we're teaching our students or they're developing are also aligned. So these are very much the skills that we've embedded into our program and given students an opportunity to learn. And I'll tell you where that happens here. So what I'm showing you now is actually the structure of the IEP. So if I lay that out, it happens in every year of the 3 or 4 year program that we have in the UK. So students can take a bachelor's degree, which is a 3-year program, or an integrated master's program with it, which is 4 years. But if you look across the top here, those are the departments that are involved in the IEP. So you should imagine from first to 4th year, that is the core elements for civil engineering in the Orange. That's their core degree. And then in the first year, we've got these cross-cutting IEP elements. The first year, that consists of mathematical modeling and analysis as a module, engineering challenges, which is also a module, but it's a project-based module and a team-based module, which happens from the first term. We have a design and professional skills module that sits alongside the project module, and we've got scenarios embedded in that as well. So our maths, just quickly to say, everyone learns maths, and maths is really quite theoretical often in the first and second year. We've changed that and flipped it on its head so that it's much more applied. Students are starting to use software and tools like MATLAB and programming to help with the mathematical modeling. It's not Calculus 101 at all. It's about how does engineers use the maths. And in many ways, it's making sure the students understand how engineers from their discipline use maths. And that continues on in the second year. So for our engineering challenges course, that's effectively 2 big projects. They're 5 weeks each, and our students work in teams to solve those larger, more longer projects. Those are interdisciplinary as well. So that is the first opportunity for students to work in teams with students from another department. So they're paired in those challenges. The design and professional skills course is quite unique in that it actually is a module about developing skills. So students learn the theory behind creative thinking, behind critical thinking, making judgments. What is the social theory behind these things? And then they apply them. So it's a very much applied course. It very much supports all the other learning that is happening. And students create almost a portfolio of work to prove that they are learning and developing those skills. The scenarios are a buzzword for us. The challenges and scenarios are projects, essentially. The challenges are 5 weeks long. Scenarios are 1 week long. And these start in the second term of the first year. But effectively, our students don't go to class as you would normally think. And for the week, they just work on a project. And that project is discipline specific. So civil engineers work on civil projects, chemical engineers work on chemical engineering projects. But they work on projects that link to the modules that they're learning at that time. So they understand that the 4 modules that they're learning are what are the common elements around them, and it's based on a project in industry. So for mechanical engineering, they do a drones project in one of the final scenarios. For biomedical engineering, they work on medical apps because they do programming as well. Biochemical engineering, they do a food scenario. So, introducing students to both the applications, but also sectors within that match their degree program. So then in the second year, we still have the mathematical modeling, and design and professional skills is another course where they are developing those skills in that portfolio. Scenarios continue, and then at the end of the second year, the students start their IEP minor, and they also enroll in what we call a How to Change the World. So the IEP minor is an opportunity for students to really specialize or personalize their degree, tailor it to their interests. And what it is students in any degree can choose a minor that is already designed for them. There are 18 choices, and actually it's quite hard for the students to choose, but they started in the second year and they continue it on in the third year. And now that we've done this for about 5 years now, 5-6 years, this is the one thing that stands our program apart. Students really like to be able to diversify their education and personalize it. I've got another slide at the end to show you what we offer. How to Change the World is quite unique. It's their last project at the end of the second year. Effectively, it's their 9th project. It's the 9th team that they will have participated in. So it gives them a lot of opportunity to build their skills before they get into their major 3rd and 4th year projects. But it's different because it's aligned with the Sustainable Development Goals, the UN SDGs, if you like. So it's socially driven, and we get all of our second year students to come together to work in multidisciplinary teams to create a technical solution to a social problem. Again, I'll show you that in the end. And then in 3rd and 4th year, there are opportunities for interdisciplinary projects as opposed to just discipline-specific major projects. This is another way of looking at the IEP. I drew this once for an industrial partner. Because the IEP has so many projects, industrial partners can come in and work with our students really from first year, not just in the 3rd and 4th year projects. So the way I drew it was, this is the journey through their education from in first year, second year, and 3rd year. The challenges, the 6 scenarios that they have, how to change the world at the end of second year, and then on to their 3rd year project. Of course, this is totally at a scale. So we've got their maths and their discipline technical, degree modules, which is, I would say up here is about 70% of their learning. That is the bulk of their work. And then we've got design and professional skills down here because it's an IEP offering. But the thing that's the most important is that the spine in the middle are the design projects or the practical applications of both their technical and their skills-based learning. And it's the arrows that are important, because in the classrooms here, fairly traditional classrooms, of the maths, the discipline specific, and the design and professional skills, come the opportunities for projects and real applications of their knowledge, mixed with some discipline projects and some interdisciplinary projects. So the learning outcomes for the IEP, one of the major one was authenticity. Like I said, the projects and the experience that we give our students is quite real. That was one of our main goals. So we ask our students what they like and they don't like much about their experience. And for this one, particularly of the engineering challenges. So again, this is the first term course where our students do projects right away and they're in teams right away. And the thing that they like the most about it is the authenticity of the work that they're doing. And authenticity can come in many ways. So they're actually doing real world problems, working with real partners. The technical task practicalities, so the building and making they like, but they also need to use their professional skills. So they're working with people in teams, they have to manage their project work and their time, they have to sometimes work with a partner, and therefore their communication skills are really, really important. At the end of most projects, they have to present. So there is so many real things that they are doing and learning and developing their skills at the same time. How to change the world. This, like I said, is that 2-week hands-on intensive project that is really aimed at giving our students the opportunity to develop their creative and technical solutions to 21st century challenges, to bring about that positive change. These are some of the SDGs that we've tackled in the past. We break them down into cohorts, and then within those cohorts, so one cohort would be, for example, clean water and sanitation. In that cohort, we then again divide them and give them two contexts. One that's an international context and one that's a London-based context. So clean water and sanitation in London would be cleaning up the Thames, which is the main river that's through London. And another was cleaning the canals in Bangkok. So we've got researchers and partners giving us data, giving us some understanding of what they've done, what the research is telling us on how that work is going through, but we're asking them a new challenge, a new question, and really looking for them to work together in interdisciplinary teams to come up with an engineering solution. So these are some of our partners, both governmental partners, they are commercial partners, international partners, as well as national partners. And at the end of it is quite a celebration, because like I said, this is the 9th project that they've done. IEP is a lot of work, but it's so rewarding. We go to City Hall, we go right across from Westminster to County Hall, actually, sorry, is quite an extravagant building. And our students do an exhibition of their work. It's quite professional. We bring in quite a lot of partners, and there are a lot of prizes, and the winners go on to be able to present their work to the partners as well as to government. So our philosophy, particularly when it comes to the IEP in the first 2 years, is that we need our students to really understand that design means bringing everyone together from the start. And that's our motto when it comes to how we approach interdisciplinarity. The minors, as they start popping up here on the screen, are a little bit color-coded. So just to remind you, the minors are an opportunity for the students when they come in after first year to tell us how they'd like to personalize their electives. So it's essentially a group of electives that start in the 2nd year and finish in the 3rd year. And they are bundled in these themes. So our students from any department can study one of these minor subjects. There are, of course, some caveats, like applications for programming down at the bottom for data science. That is those two actually are computer science taught programs. So they come out of our computer science program department. The computer scientists cannot do the programming minor. It is for anyone else that's not a computer scientist. But the AI or the intelligent systems course is open to everyone. So there are a few exclusions if that element of learning is already quite fundamental. So across the top, entrepreneurship, finance and accounting and management come out of our globally renowned School of Management course. Programs. We've got biomedical engineering and regenerative medicine that come out of our award-winning programs in biochemical engineering, biomedical engineering. Crime and security engineering is from our newest department, and it is at the moment very much electrical engineering and computer science based. Nanotechnology and connected systems comes out of electrical engineering. We've got environmental engineering coming out of civil engineering. Applied chemistry and molecular engineering comes out of chemical engineering. Modern applications of engineering maths is actually a team-based cross-faculty effort, because students want to understand where their engineering maths are being applied. So there are 3 modules on that give the students an opportunity to understand where else in different industrial sectors is our engineering maths really applied. And because we are in London, lots of our students go to the city, and so financial maths and trading is a big part of that minor. Ocean engineering comes out of mechanical engineering, and that's where they design vessels. Engineering design for society, that is very much takes its protocol from How to Change the World. So international development there, but really focusing on engineering and being a designer for people. We've got modern languages. So if students don't want to do anything technical at all, they can go outside of the faculty. And then we've got a very unique offering here with strategic learning here in engineering and technology, as well as engineering and public policy. So the more social side of engineering, the first being more about journalism and the second about public policy. So what makes us different? Students learn authentic engineering workplace practices through several project opportunities, which is completely unique to us. Students learn to work with engineers from other disciplines from the start. They develop their skills so that they can turn their theoretical work into real solutions. And the IEP gives them that time to kind of develop their ideas, their confidence to pitch their ideas to their teammates, but also to develop themselves, to make the most of their education, as well as to understand what type of engineer that they'd want to be, or perhaps the type of work that they'd like to go into, even if it's not engineering after they graduate. So just before I finish, what we believe is inherent in the IEP are these elements. And we started focusing on these aspects of their students' learning after we put the program in. So once the students started working on projects and working in teams, we now have much more structure to help them with their teamwork. If students want to go beyond and learn more about their own leadership styles and project management, there are extra courses that they can take. Student-led learning and autonomy. So we're asking the students to really go above and beyond what is being taught in the classroom to do more in their projects and their own research. Self-awareness and self-efficacy, ethics, values, and morals comes in. Sustainability and safety is embedded in everything. Global challenges and societal impacts are now being introduced from the day one. And students really come with a passion for these. So it aligns with a lot of students' reasons for coming to UCL. Lots of non-traditional pathways. Our students graduate, 50% of our students graduate and go on to doing non-engineering careers. And the way the students learn is much more inclusive and diverse, mainly because of the team aspect of it and the way we support them in that. So as was mentioned in the beginning, we are part of this report that MIT put together. Ruth Graham was the author of it, and we've been highlighted as an emerging world leader in engineering education. We take this role very seriously. We have a symposium every year with those that are also considered to be world leaders, inviting those that want to improve and do more in their own programs and in their own schools. The purpose of that report was because actually MIT are wanting to transform their offering as well. And they want to learn from those that are already doing it or have already done it. So that was actually the purpose of the report. And so it's really interesting to understand of those 50 global thought leaders that were interviewed, what comes out of that report and what's most predominant in terms of what they think the future of engineering education is. So that's the last of my slide. I hope it didn't go too fast, but I'm here to take some questions.
Thank you very much, Emanuela. It was indeed very interesting. We are very short on time for the next presentation. I think many people will be willing to have 30 minutes more for the questions.
Sure.
We don't have that. So yeah, the first question I think everyone is asking is how can I enroll in UCL? But let's not go to that one. I have one question from the audience. Which is, do students at UCL have some kind of tutoring to help them choose the minors?
Yes, so at the end of the first year, we have quite a lot of information. So in January, we have a fair, so they have an opportunity to meet students from the past that have taken it, as well as their academic leads. We have quite a lot of lunch sessions so that they can get a sneak peek into what they'll be learning. So almost like mock lectures so that they can participate, as well as they get personal tutors know all about the minors, and we give them a lot of information. So hopefully their personal tutors are helping them make the decisions. But actually at the end of the day, we find their family and their friends help them make those decisions. But we give them about, I would say, about 4 months of to kind of get up to speed before they have to decide.
Thank you. And I just have one more question because we are really out of time. So I like also you not to prolong too much. Um, so what were the main challenges and barriers to implement such a big change in UCL engineering? And what would be your recommendations for some education leaders that some might be hearing us to
Yeah.
implement changes in their own curriculum?
Yeah, I mean, one of the things that was the biggest barrier was we implemented the change in a rolling way. So we started with the first years, and then as they graduated, we went to the second. As they progressed, we continued on. So at any one time for the first 4 years, there were students that were not on the IEP and those that were on the IEP. So the way we promoted it, the way we communicated it was really important, not to devalue the experience of those that didn't do the IEP, but also encourage the first year students that what we were doing would benefit them in the long run. Because peer-to-peer interaction is really strong, fourth year students influence first year students so much. So because the fourth years didn't do it, those were really difficult for the first 4 years to really make that transition. So getting students involved to make sure that it evolves and we get peers helping us develop it was something that we took on right from the beginning, so that the fourth year students gave us feedback and we made the program based on their experiences. And then staff. So a lot of staff weren't actually very courageous in their teaching. So teaching projects or facilitating projects is different than lecturing. So we had to get the staff on board to try to understand how they can change their teaching and how it impact a lot of their teaching. So that was pretty much it. It was getting the voice of the students as well as the staff involved while we were developing it in the first 3 or 4 years.
Thank you very much. That's also a bit of what we are trying to do here with this summit, trying to get people together, students and educators to together reshape education. And speaking of innovative education approaches, we are going now from London to Barcelona to hear about Learn Life and the new learning paradigm. So stay tuned.